we are going to formalize domain and range in your notes. So in your notebooks, title it domain and range. And what we're going to do is we're just going to fill in the right sheet of your paper for domain and range. And I'm going to define domain and range for you, and then I'm going to do two different examples, and we're going to list the domain and range for them, just so that you can see more of a formalized process of how domain and range are written, because notation is going to be important. So, domain. Domain is just the set of all possible input values. Remember, those are your x values. Versus the range is the set of all possible output values. Which are the y values. So domain, you're looking at all your x's. Range, you're looking at all your y's. So an example, we're just going to do a quick sketch of this. It doesn't have to be anything fancy. At 2, -1, we're going to put the vertex. And then honestly, from there, it doesn't matter at all. So we're just going to draw a parabola-looking shape. Okay, so this is that lowest point. So when we do our domain and range here, we're going to look specifically at the x's and y's. So for domain, I'm going to do that in purple. So again, remember, domain are your x values. So you're looking along the x-axis. If you were to make a table, which x values would you have? Would you have a value at -1? Yep, there's a point up here. Would you have a value at 0? Yep, it's here. Do you have a value at 1? Yep. 2? Yep. 3? Yep. Etc. So it goes both directions forever. So we would say all real numbers for this. So if you really want, you can write out the words, all real numbers. Or, even easier, would be 2 vertical lines with the r through it. Or, you can say x is greater than -infinity, but less than infinity. Please note, whenever you write infinity, it cannot equal infinity. Infinity isn't a number. It's the idea of where our numbers are heading, but it's not a specific number. Do not put an equal, otherwise you are going to get points off. Okay, so that's your domain. For your range, I'll do that in y. So your range are your up and down values. So when you look at your up and down values, do you have a value at -1? You bet, it's right here. Do you have a value at -2? No. So you do not have any values down here. So now you look, do you have values at 0? Yep, I have 2 of them. Do you have a value at 1? Yep. 2? Yep. 3? Yep. Etc. So therefore, for the range for this problem, it has a definitive starting point. So therefore, y is greater than or equal to -1. It equals it. And you can leave it just like that. Or you can write y is greater than or equal to -1, but less than or equal to, oh, shame on me, less than infinity. So it keeps going from here up in this direction. So therefore, it goes from -1 to infinity. Okay, second example. For this one, we're going to put a few tick marks on here. Okay, so we have a point at -2, 1. We have a point at 0, 3. We have a point at 2, -1. And we have a point at 4, 2. And we're going to just connect those. So I'm going to do that in a different color so you can see it. Here we go. We go here, here, down, and up. And that's it. There are no arrows. So it has distinct starting and stopping points. So domain. When I look at my domain values, do I have an x value of 0? Yep, over here. Do I have an x value of 1? Yep, up here. At 2, down here. At 3, yes. At 4, yes. At 5, no. But do I at 0.5? Yep. How about -1? Yep. -2, yes. -3, no. So therefore, it is just those values. So my domain has a start and a stop, so both ends. So therefore, x is greater than or equal to -2, but less than or equal to 4. And again, because they're closed on both of them, it equals it. I'll do an open one in just a minute. For range, when I look at my y values, my range values, look at up and down here, because these are your y's. What's the lowest value? -1. What's the highest value? 3. And it's everything in the middle. Therefore, y, because it's my range, is greater than or equal to -1, but less than or equal to 3. So that's your domain and range. If by some chance, I'm going to change this problem up just slightly. If this was an open circle here, if that was an open circle, then my domain, my x values, would go from -2 to 4, but it doesn't include 4. In my range, my y values, y would be greater than or equal to -1 still, less than or equal to 3. Now there's an open circle here. However, at this point, there's a point here, so it doesn't have to exclude anything in here. Every single possible value along my y-axis is included between -1 and 3. Okay, so there you go.